All right, so here we're going to take a look at all the different types of factoring put together. And, we're going to have to think about when to do what. Okay, so in number 62, we have a trinomial. Now remember, the first thing you want to say to yourself is, can I factor out a greatest common factor? Which we cannot. So this is a pretty straightforward one. Because there's a 1 in front of the first term right here, this is where we just set up two sets of parentheses. We take the square root of this first term, so the square root of x squared is x, and that goes in the first spot in each parenthesis. And then we just come up with two numbers that add to the middle term and multiply to the last term. Okay, remember, if they multiply to a negative, they have to have different signs. So we already know right off the bat, one of these has to be positive and one has to be negative. It doesn't matter, which sign you put in which parenthesis, as long as you attach the right number to each of these. Okay, now, two numbers that multiply to negative 30 and add to negative 13, and it may take a little trial and error, is going to be a negative 15 and a positive 2. So I'm going to put the 15 with the negative and the 2 with the positive. Okay, if on accident I reverse these numbers, if I had a positive 15 and a negative 2, that would have added a positive 13. We don't want that. We want a negative 13. Also, one thing I want to point out, some of you guys might have seen these two numbers and been thinking 10 and 3, but unfortunately, because they have different signs, if you use a 10 and a 3, they're not going to add to negative 13. Okay, number 63. Now we have two terms. Again, the first thing you want to say to yourself is, can I factor out a greatest common factor? And sometimes you can, sometimes you can't. The other thing you want to look for with two terms is, do we have dots, a difference of two squares? All right, well, let's start with greatest common factor. You could see right here, we definitely can pull out a greatest common factor, right? We could pull out a 4, which is going to leave us with 25 minus x squared. All right, and then we want to look in the parentheses. We want to say, can I factor this further? And yes, you totally can. We have a difference, and both of these two terms are perfect squares. So when that happens, we know with dots, we open up two sets of parentheses. One gets addition, the other gets subtraction, and we take the square root of this first term and put it in the first spot in each parenthesis. And we take the square root of the second term and put it in the second spot in each parenthesis. And the other thing I don't want you to forget to do is to bring down this 4. Okay, that's one of your factors as well. All right, since we can't factor further, that's it. That's our answer. All right, I'm going to go back. I like to kind of either circle or box off the answers to say, this is my final answer. All right, now when you look at number 64, remember when you have two terms, right, there's one of two things you could do. You could either factor out the greatest common factor, or if you can't do that, you look and see if you could do dots. But if you look here, we can factor out a greatest common factor. Look, they both have an x. So let's pull that out. All right, once you pull out the x, it leaves you with x minus 3 in parentheses. Now, if you look in the parentheses, this is not a difference of perfect squares. Although it's a difference, these are not perfect squares. So that's it. That's all we can do with this one. All right, on to 65. Now we have three terms, okay? This is a trinomial. We say to ourselves, can I pull out a greatest common factor? Which I can't. So look, this one's different than number 62. In 62, we had a 1 as our leading coefficient. Here we have a 6 as our leading coefficient. So remember, if the number in front of the first term is anything other than 1, we do not set up two sets of parentheses, okay? We only do that when we have a 1 here. If it's a number other than 1, this is where we bring down the first term, we leave a big space, and we bring down the last term. And then we have to come up with two numbers that multiply to this rainbow number. Okay, we get the rainbow number by multiplying 6 times negative 12, which is negative 72. So we have to come up with two numbers that multiply to our rainbow number and add to the middle term. So they're multiplying to negative 72 and adding to negative 1. Right, and again, it may take a little bit of trial and error. You may have to use the calculator tricks we learned, right, where you can go to y equals and type in negative 72 divided by x, and go to your table of values and scroll down until you find two numbers that add to negative 1. Well, once you finally do, you'll see you wind up with a negative 9 and a positive 8. Okay, now, since this is a b, we need to attach b's to these. All right, and now we've created 4 terms, so now we could do grouping, right? We group together the first 2 terms, and we group together the last 2 terms. Okay, and just one thing I want to remind you, please do not put parentheses like this around those terms, because parentheses mean that we are multiplying, right? It means we're going to multiply out these 2 binomials, and that is not what we're doing. So if you put parentheses, get rid of those. All right, so now when we look at the first 2 terms, we could take out a 3 as well as a b. And then when we do, right, just to remind you, 6 divided by 3 is 2. And if we had 2 b's and we took one out, we still have a b to put there. Okay, then we bring down our minus sign. And 9 divided by 3 is 3. And we had a b, but we took it out so we can close up this parenthesis. All right, now let's look at the next 2 terms. Looks like the only thing we could take out of these is a 4, right? A positive 4. So please don't just write 4, right? What do we need to put in front of that? The sign of the number we took out. So we took out a positive 4. Okay, without that plus sign there, the expression is unfortunately not equivalent to the ones above it. Okay, so then in parentheses, that leaves us with 2b and then minus 3. All right, and it always feels good to see the same thing in the parentheses, because then it lets us know, all right, we are on the right track. So we're going to take what's in front of the 2 common parentheses, so the 3b and the plus 4, and we're going to group them together as one of our factors. And then we're going to take that common parenthesis, the 2b minus 3, and we're going to rewrite that once only. All right, and if you look within the parentheses, there's nothing we can do to factor further, so this is our answer. All right, so let's take a look at the ones on the bottom of the page. So let's start with this, number 66. All right, so we have a trinomial, and I know you do see a number other than 1 in front of the first term, but remember, what's our first step in factoring? Can I pull out a greatest common factor? And if you look at these 3 terms, we definitely can, right? We could pull out a 4, so let's do it. So we pull out a 4, it leaves us with x to the 4th minus x squared, and then just minus 2. Okay, now when we look at our trinomial that we're left with, there actually is a 1 as the leading coefficient. So when there's a 1 as the leading coefficient, we don't, I mean, technically you could do the rainbow, but that's just a long process, more steps, more room for error. I do not recommend doing the rainbow and factor by grouping if you have a 1 here. Okay, so I'm not going to show it that way. If you want to do it that way, that's your choice, but it just creates much more room for error. All right, so anyway, this greatest common factor is going to come down, and I'm just going to factor this like any old trinomial that has a 1 as a leading coefficient, right? We set up 2 sets of parentheses. We take the square root of this term and put it in the first spot in each parenthesis. So the square root of x to the 4th would be x squared. And then we just come up with 2 terms that add to the middle term, so add to negative 1, and multiply to the last term, so multiply to negative 2. Now remember, if they multiply to a negative, it means that we're going to have 1 of each sign. So we're going to have a positive as well as a negative. All right, so the 2 numbers that multiply to negative 2 and add to negative 1 would be negative 2 and positive 1. I just want to point out we cannot factor either of these further. Although we have a difference here, okay, this is not dots because 2 is not a perfect square. And in the first parenthesis, although both of these are perfect squares, this is not a difference, so we cannot factor that further. Okay, if you have 2 terms, you can only do dots if there's a subtraction sign there. All right, so there we go. All right, number 67. So again, we do have a number other than 1 in front of the first term, but if you look at all those terms, we're going to be able to factor that out, right? We could factor out not only a 5, but also an x out of each of those terms. Okay, and when you factor out a greatest common factor, we write what we're left with in 1 parenthesis. Whenever you factor out a greatest common factor, don't try to set up more than 1 parenthesis. All right, so it leaves us with, in the parentheses, x to the 4th plus 9x squared plus 20. All right, so if we look at our trinomial, we'll say, look, again, we have a leading coefficient of 1. And when there's a 1 in front of your first term, don't waste your time doing the rainbow, okay? It's time-consuming, lots more steps, and, more room for error. So we know that we're going to set up 2 sets of parentheses. And we're going to take the square root of this first term and put it in the first spot in each parenthesis. And then we're going to come up with 2 numbers that add to 9 and multiply to 20. All right, well, if 2 numbers multiply to a positive, it means they have to have the same sign. And since they're adding to a positive, it means they are both positive. All right, this one's not too bad. So 2 numbers that multiply to 20 and add to 9 would be positive 5 and positive 4. And remember this 5x right here. Bring that down, okay? I usually bring it down right in the beginning so I don't forget, but I wanted to just make sure I pointed it out to you guys. All right, so I left it for now. All right, now because there's addition signs within our parentheses, as long as you had factored out the greatest common factor from the beginning, you're not going to be able to do anything else here. So this is our final answer. Now, I just want to point something out because I know, I've had a bunch of people say to me in the past, what about this x squared right here? Do I have to put an x and an x on these? Well, let me show you why you don't have to. I'm just going to show you really quickly how you could check this if you want. Okay, don't worry about the 5x. I'm just going to show you how this, right, x squared plus 5 times x squared plus 4 multiplies out to give you this. All right, if you were to check, right, we would do x squared times x squared, which would give us x to the 4th. I'm just doing a check down here. Then we would do x squared times 4, which is 4x squared. Okay, now we're going to distribute the 5 to both terms, right? So 5 times x squared is 5x squared. And then 5 times 4 is 20. And if you did combine these like terms right here, wouldn't these combine to give you that 9x squared in the middle, right? Here's the x to the 4th. These would combine to give you 9x squared, and then we have our 20. So that's really what takes care of that middle term. If you had put x's on these, then 5x times 4x would be 20x squared, and we don't want that. We want this to be 20. Okay, so this right here checks out. All right, so number 68. So again, first thing we say to ourselves is, can I factor out a greatest common factor? Which, yeah, you definitely can, right? Look at these numbers. You could pull out a 4. So when you do, it's going to leave you with 6x squared plus x minus 2. Okay, so let's bring down that 4 that we factored out. And now if you look in the parentheses, right, this trinomial has a number other than 1 in front of the first term. So please do not try to set up 2 sets of parentheses, okay? We're going to open a parenthesis just because we have the 4 out here. But you bring down the first term and leave a big space and bring down that last term. And the reason I leave a big space is because, remember, I have to fit 2 terms in here. All right, so let's multiply the first and last term, right? So 6 times negative 2 is negative 12. And then let's find 2 numbers that multiply to negative 12 and add to positive 1. Okay, so it looks like that's going to be positive 4 and negative 3. And since this is an x, we're going to put an x attached to each of these. All right, so let's group. Now first let's bring down the 4, open up a parenthesis. And if you prefer to use a bracket here instead of parentheses, just because we're going to need more parentheses, and if you get confused with parentheses within parentheses, you could just use a bracket here. That's up to you. Okay, but anyway, I'm going to group together these first 2 terms and group together the last 2 terms. And out of these first 2 terms, I could pull out a 2 as well as an x, so 2x. So that's going to leave me with 3x plus 2. Okay, now if I look at these 2 terms, I have to decide, do I want to factor out? I mean, the only thing you could factor out is a 1. So do I want to factor out a positive 1 or a negative 1? Well, I want to get the negatives out of here because I want to be left with a positive 3x and a positive 2 in my parentheses. So I'm going to factor out a negative 1. And when I do, it's going to leave me with a positive 3x and a positive 2. Now, not only do I have to close this parenthesis, but remember this parenthesis I opened up? Or if you chose to use a bracket, you could close it up as a bracket. Okay, but I did a parenthesis, so I'm going to close it up as a parenthesis. All right, so now let's just bring down the 4. Our first factor is going to be the numbers in front of the common parentheses, so the 2x minus 1. And then we're going to bring down the 3x plus 2 just once. All right, and if you look, I mean, there's really nothing else we could factor within those parentheses, so this is our answer. All right, and then number 69. So when you look at those three terms, we cannot factor out a greatest common factor. So since we have a number other than 1 in front of the first term, we know we're going to do the rainbow. So we bring down the first term, we leave a big space, and we bring down the last term. And what the number we put on the rainbow is we multiply together 9 times 4, which is 36. All right, so we need to come up with two numbers that multiply to 36 and that add to negative 12. So negative 6 and negative 6. And I'm going to attach an x to each of those because if you look at our original expression, the middle term had an x, so it has to go next to those. Okay, so then we're just going to group. When we group together the first two terms, we could pull out a 3x, which is going to leave me with 3x minus 2. And out of the last two terms, you have to decide, do you want to factor out a positive 2 or a negative 2? Well, since within the parentheses we have a positive 3x and a negative 2, the only way to get that to happen in our second set of parentheses is to factor out a negative 2. I mean, an easy way to look at it is, see how this sign goes positive, negative, whereas this goes negative, positive? If these have the opposite sign as what's in our parentheses, it means we want to factor out a negative. So let's factor out a negative 2, and then I'll be left with positive 3x minus 2. Okay, so we can group together the 3x and the minus 2, right? The terms that are in front of those common parentheses. And then we're going to bring down the 3x minus 2 that's in the parentheses just once. Now, you can leave your answer like this, or, I'm going to write or here, if you want. Remember, if you have two of the same factors, you could rewrite it once and just put a square on it. So either one of these is fine. All right, number 70. So we have two terms. Now, first thing you always want to say is, can I factor out a greatest common factor? Which you can. We could pull a 3 out of both of these terms. So it leaves us with x to the 4th minus 16. Okay, so now when you look in the parentheses, you want to say, can I factor further? If we have two terms, we're looking for a difference of perfect squares, and both of these are perfect squares. So let's bring down the 3 and open up two sets of parentheses. One's going to get addition, the other gets subtraction. And we take the square root of this first term and we put it in the first spot in each parenthesis. And we take the square root of the second term and put it in the second spot in each parenthesis. Now, if you look at your factors here, we can factor further. We have another difference of perfect squares here. Okay, this we can't factor further because of the addition sign. So let me just bring my 3 down. Bring down the x squared plus 4, right? You always want to bring down what can't factor further. And since this is what factors further, we know with dots, we set up two sets of parentheses. We put an addition sign and a subtraction sign. We take the square root of the first term and put it in the first spot in each parenthesis. And then we take the square root of the second term and put it in the second spot in each parenthesis. And from this point, there's, nothing else that factors further, so this is our answer. Okay, in number 71, you want to look and say, can I factor out something from all 4 terms? No, we cannot. So when you have 4 terms, we know we want to group. We group together the first 2 terms, and we group together the last 2 terms. So out of the first 2 terms, we could pull out an 8r squared, which is going to leave me with r minus 8. And then there's nothing other than a 1 we could factor out of these two terms. So we want to decide, do we want to factor out a positive 1 or a negative 1? Well, in order to get the same thing as we have in this parenthesis, a positive r and a negative 8, we have the opposite. We have a negative r and a positive 8. So we're going to have to factor out a negative sign. Okay, so a negative 1. Remember, if this goes plus minus and this goes minus plus, if they have the opposite signs, we're always going to factor out a negative, which in this case would be a negative 1. And that is going to leave us with a positive r and a negative 8. All right, and then we could just group together the 8r squared and the minus 1. And I'm going to bring down that common parenthesis of r minus 8 just once. And, I mean, you want to look and say, are either one of these a difference of perfect squares? No, they're not. So there we go. There's our answer. All right, number 72 is actually similar to 71. All right, if you look at all of these terms, there's nothing you could factor out of all 4 of them. So we're just going to jump right into grouping. I'm going to group together the first 2 terms and group together the last 2. So to the first 2 terms, we could pull out a 3x squared, which is going to leave us with a 2x minus 1. All right, of the last 2 terms, we could either pull out a 5 or a negative 5. Now remember, if we want a positive 2x and a negative 1, okay, this is positive negative, whereas this is negative positive, okay? These have the opposite signs of what we want in our parentheses, so that clues us in as we have to factor out a negative. So let's factor out a negative 5, which is going to leave us with positive 2x minus 1 in parentheses. Okay, so now let's group together the 3x squared and the negative 5. Let's group together what's in front of the parentheses as our first factor. And let's rewrite that common parenthesis, the 2x minus 1, as our second factor. And since neither of these is a difference of perfect squares, right, when we have 2 terms and we can't factor out a greatest common factor, that's really all we're looking for. If we can't do that, we know we're done. All right, now 73. We have a trinomial. Now, if you notice, these exponents are not going in descending order, right? This is x to the first, x to the fifth, x cubed. Whenever you have, a trinomial, you really do want to rewrite your terms so that the exponents are in ascending order. So I'm going to write the negative x to the fifth first, the term with the biggest exponent. Then we have the negative 23x cubed. Remember to keep the signs with the terms. And then finally, we have this positive 50x. Okay, so the first thing we want to do after rearranging is say, can I pull out a greatest common factor? Now, they all contain an x, so we could pull out an x. We can't pull out more than 1 because this term only has 1. So you want to decide, do I want to pull out a positive x or a negative x? Well, remember, if the leading coefficient, if that first term has a negative, we're pulling out a negative. So when I pull out a negative x, remember, when you pull out a negative, basically all your signs are going to change. See how this went negative, negative, positive? In our parentheses, we're going to have positive, positive, negative. Okay, so if I had 5 x's and I took 1 out, I have 4 x's remaining. So it's positive x to the 4th. And then since a negative divided by a negative is a positive, I'm going to bring down that 23, and I had 3 x's, and I took 1 of them out, so I still have 2 left to put in here, so x squared. And then 50 divided by negative 1 would be negative 50. Remember, the sign changes. And I had an x, but I pulled it out, so I'm going to close these parentheses up. All right, so let me bring down the negative x, and let's factor this trinomial further. Now, since we have a 1 in front of our first term, we're not going to do the rainbow and make it into 4 terms and grouping, right? That's totally unnecessary. We know whenever there's a 1 in front of your first term, you just set up 2 sets of parentheses. You take the square root of this first term and put it in the first spot in each parenthesis. And then let's just come up with 2 numbers that add to 23 and multiply to negative 50. All right, so I guess that would be what? Positive 25 and negative 2. And neither one of these is a difference of perfect squares. I mean, these are perfect squares, but we don't have a difference. This is a difference, but 2 is not a perfect square. So we can't go any further. So I'm just going to circle my answer. That's it. All right, so let's take a look at number 74. All right, so we have 3 terms. We have a trinomial, and if you look, there's no greatest common factor we can factor out. Now, we do not need to do the rainbow, right? Because there's a 1 in front of our first term. So we just set up 2 sets of parentheses. We take the square root of this first term. Now remember, when you're taking the square root of a term with an exponent, all you're really doing is cutting that exponent in half. Okay, half of 12 is 6. So the square root of this is x to the 6th. Because x to the 6th times x to the 6th is x to the 12th, right? When you're multiplying 2 terms with the same base, you just add these exponents. All right, so now let's come up with 2 numbers that add to negative 24 and multiply to negative 25. All right, well, if they multiply to a negative, we know we're going to have 1 of each sign, right? So one of these is going to be positive, and one of these is going to be negative. All right, so it looks like if they're going to add to negative 24, we're going to have a negative 25 and a positive 1. All right, so now let's look and say, can we factor further? This one we can't because there's an addition sign. But this one we have a difference, and both of these are perfect squares. Remember, as long as it's an even exponent, it's a perfect square. You know, I always like to plan ahead too. I mean, I like to put whatever term I realize is going to factor further last, like on the right, because I like to always just bring down first whatever I can and then factor further whatever I can. But, you know, that's up to you if you want to do that. All right, so I'm going to bring down the x to the 6th plus 1. And then since this is dots, I'm going to set up 2 sets of parentheses, put an addition sign in one, and a subtraction sign in the other, and I'm going to take the square root of this. Remember, when you take the square root of a term with an exponent, you just cut the exponent in half, right? So half of 6 is 3. So the square root of x to the 6 would be x to the 3rd. And then I'm going to take the square root of 25 and put that in the second spot in each parenthesis. Okay, so if you look here with what we have, none of these can be factored further. So I'm going to circle this. All right, number 75. So when we look at this, I mean, the first thing you want to say is, can I factor out a greatest common factor? And you notice we have a's and b's. And when you have 2 different variables, if you want to write it in standard form, think about alphabetically what comes first, right? A comes before B. So you want the exponents on the A to go in descending order. So we have a to the 4th, a squared, and then really a to the 0 because there's no a's here. So this is in standard form. But if you look at the numbers, we could pull out a 4. We can't pull out any variables, because this term doesn't have any b's and this term doesn't have any a's. So I'm going to pull out a 4. And when I do, I'm going to put in one big parenthesis what I'm left with after I basically divide each of these terms by 4. Okay, now even though we were able to pull out a greatest common factor, we still have a number other than 1 in front of the first term of our trinomial. So when that happens, we know we're going to bring down the first term, leave a big space, and bring down the last term. And we're going to make a rainbow from the first term in our trinomial to the last term. So 6 times negative 20 would be negative 120. So we want to come up with 2 numbers that multiply to negative 120 and that add to 7. Okay, so that's going to be positive 15 and negative 8. All right, I'm going to put, it doesn't matter what you put first, I'm going to put the negative 8 first and the positive 15 second. Now, if you notice, attached to this middle term, we have a squared, b squared, so that's what I have to put here and here. Okay, so we're going to have a squared, b squared. Okay, and now we're going to group. So remember, this 4 comes down, and you can either open a parenthesis, or if you don't like parentheses within parentheses, you could make this a bracket. And then we're going to factor the greatest common factor out of these first 2 terms, which would be a 2a squared. All right, so then in parentheses, we'll have 3a squared minus 4b squared. Okay, just to explain that, 6 divided by 2 is 3. We had 4 a's and we took 2 of them out, so it leaves us with 2 of them still. Negative 8 divided by 2 is negative 4, and we had this a squared, but we took it out, so we just brought the b squared down. Okay, now out of these two terms, we can factor out, it's like a positive 5 as well as a b squared. So I'm going to write plus 5b squared. There's a lot going on this one, right? All right, so that's going to leave us with 3a squared minus 4b squared. So I'm going to close that parenthesis, and don't forget this one that's open, we have to close that as well. All right, so I'm going to bring my 4 down. I'll take what's in front of our common parenthesis and group those together as one of our parentheses. So 2a squared plus 5b squared. And then I'll take that common parenthesis and rewrite that once. And if you look at what we're left with within the parentheses, there is no difference of perfect squares, and we've already factored out the greatest common factor, so this is our final answer. Okay, so it looks like the last two on this page, they both have 6 terms. Now we know with 6 terms, you could do one of two things, right? We can either group this into 2 groups of 3 or 3 groups. Oop, that was a little messy, of 2. So I always think it's a good idea to look ahead and see what seems to make most sense. But if you have a hard time doing that, just try them both out. All right, so I'm looking at these, and it looks like if we group them in 3 groups of 2, right? If you pair them off, see how that's a 1 and a 9? I'm not worrying about the signs right now. A 1 and a 9. And if we factored out the greatest common factor for 20, we would have a 1 and a 9. So I'm thinking that 3 groups of 2 is going to work out better for us. So let me get rid of this, and let me group this into 3 groups of 2. Now remember, if you can't do that off site, that's okay. Just try out, both groups, 2 groups of 3 and 3 groups of 2, and see which one leaves you with the same expression within the parentheses. All right, so to these first 2 terms, I'm going to factor out an x squared, which leaves me with x squared minus 9. Out of the next 2, I'm really just factoring out a negative x in order to be left with that x squared minus 9. And out of the last 2, I'm factoring out a negative 20. And that's going to leave me with that same thing, the same expression within the parentheses, x squared minus 9. So now we're going to take what's in front of each of these parentheses, and we'll group them as our first factor. And let's rewrite that, x squared minus 9. All right, now if you look in these parentheses, they can both be factored further. This is a trinomial, so as long as we can come up with 2 numbers that add to negative 1 and multiply to negative 20, that's supposed to be an m, huh? And multiply to negative 20, we can factor this further, which there are, right? Negative 5 and positive 4. So since there's a 1 in front of our first term, that's the quick type of factoring with trinomials, right? We just set up 2 sets of parentheses. We put the square root of the first term here and here, and then the 2 numbers that multiply to negative 20 and add to negative 1, we said were negative 5 and positive 4. All right, now if we look here, this is just a difference of perfect squares. This is a dots, difference of 2 squares. So I'll set up 2 sets of parentheses. One gets addition, one gets subtraction, and the square root of the first term goes in the first spot in each parentheses, and the square root of the second term goes in the second spot. All right, and we can't do anything else with this, so this is our answer. All right, and then finally, the last one on this page. Again, with 6 terms, you want to decide, am I going to group it into 3 groups of 2 or 2 groups of 3? All right, well, you could do trial and error, or you can kind of look at it and see. I mean, here, if I were to do 3 groups of 2, right, I would, if I factored out a 5, I'm just worried about the numbers. If I factored out a 5, right, I'd be left with a 1 and a 6. Here, I could factor out a 2, which would leave me with a 20 and a 1. That's not going to work. Okay, if I try to group it into 3 groups of 2, I'm going to run into a dead end. If you're not sure, if you can't just look at it and see that, then try it out. So what I'm going to do instead is I'm going to group this into 2 groups of 3. Okay, so when I do, not only can I factor a 5 out of these terms, but I could also factor out an x squared. So I'm going to factor out a 5x squared. And that's going to leave me with x squared minus 6x plus 8. All right, now to these 3 terms, in order to be left with a positive, negative, positive, see how this does the opposite signs, negative, positive, negative, I'm going to factor out not only a 2, but a negative 2. And negative 2 is what's going to, reverse those signs so that I have the same thing within the parentheses. Because a negative divided by negative is positive, so we have positive x squared. A positive divided by a negative is a negative, so it's going to give us negative 6x. And a negative divided by negative is positive, so positive 8. And now our parentheses match up. All right, so I'm going to take what's in front of them, the 5x squared and the minus 2, and that becomes our first factor, which is not going to factor further for us. Okay, that's, if you have 2 terms, you're looking for dots, and that's not dots. And then I'll take my common parenthesis, in this case it's a trinomial, and I'll bring that down. Now this trinomial is probably going to factor further for us. If we can come up with 2 numbers that add to negative 6 and multiply to 8, then we can factor this further. All right, so there are 2 numbers, right? Negative 4 and negative 2. So because there's a 1 in front of our x squared, I'm going to set up 2 sets of parentheses. I'll put the square root of x squared here and here. And the 2 numbers that multiply to 8 and add to negative 6 are negative 4 and negative 2. And then let's not forget to bring this down. And that, my friends, is our answer.